Okay, so this is our circuit. It is working. It is putting out a sound which we can change the pitch of by covering up this photoresistor. So the darker the input it gets, the lower the sound. And turn it off for now. So the basics of our circuit is we have a square pulse generator on the left, and on the right it gets fed to an amplifier circuit powered by a 386, and the overall diagram looks sort of like this. So
we can pull out the photoresistor here and insert a pot into there, which gives us a significantly better range of frequencies. So hopefully for Project 2 we'll find a way to mechanically control this with LabVIEW.
Yeah, I guess. Well, this one, I think this one might have been like 100.
Oh boy, that's...
So you see, as the potentiometer gets turned, the pitch goes up, and the potentiometer has a much higher range than the photoresistor.
I could probably turn it off.
So in Project 2, what we're going to do is we're going to connect this to a Lego motor, and it's going to get turned by the amount that distance meter that is also Lego Mindstorms tells it to. So we're basically making an instrument called a theremin.
It's probably also worth mentioning that we designed this, which has an LED above a photoresistor kept inside of a small sheath made of shrink material, and we had this controlled by the LabVIEW and LabJack. And what we had happen was when we used the infrared sensor to detect a distance, and we translated that directly into the voltage output into this LED, which in turn controlled the resistance of the photoresistor and changed the frequency. However, that did not have a very good range, so we scrapped that.
Yeah. So the major components of our circuit are the 555 timing chip, which you can see here, and basically it puts out a square pulse, but it's not really a true square pulse because it looks like that, so it's kind of like little dips. And the frequency at which that pulse gets output depends on this resistor, this capacitor, and this second resistor R1, which is actually a potentiometer in our case, or the photoresistor. And in the amplifier circuit, the really only component is this 386 op amp, and we have another potentiometer, which is right here, the white thing, and that's for volume control, but we don't really do that. So some things we learned are don't trust that book, because the circuit in the book actually did not work. The circuit told us to put a capacitor right here instead of a resistor right before the speaker, and it actually didn't work. It created a really nasty background noise at around 90 hertz, so we replaced it with this high power resistor that can take a lot of volume. So actually we blew out a resistor, and that's pretty much it. 555 and 386.
We also learned the essentials of pairing a proper capacitor and resistor in order to determine the frequency, because through a lot of trial and error we came up with some really bad frequency ranges until we finally were able to recover this 250 k ohm potentiometer, which in turn gave us a great frequency field.
So for the next project, what we want to do is basically automate the pitch using LabVIEW, and then for Project 3, maybe have it read out the frequency of the current sound into a data sheet of some sort. So we wanted to show you one of our earlier designs for the theremin, where we used the photoresistor with LabJack and this infrared monitor or whatever. So Taylor wants to go into the circuit details with you guys.
And Alexa does. So our infrared reader, this initialized everything. Our infrared reader puts out a signal from 0 to 200 centimeters. So we basically limited it to a max of 40 centimeter range, and then we divided that by 8, giving ourselves an output to the LabJack of a maximum of 5 volts from 0 to 5. And basically that allows us to use the infrared sensor to vary the voltage going to an LED directly above our photo resistor, and that in turn affects our pitch.
So if we turn it on, and here, hold this, and turn back to it on. So you can see that as I move my hand closer, it changes the pitch. It's pretty crude, but it works in design.
We decided to scrap this part of the project because it didn't have the range of frequency that we wanted that the pot gave us. So for our next project, hopefully we're going to be able to integrate the pot in there and make it a little bit more effective.